So now I'm going to move on to the second video of this section A, and this is where you're going to actually should be learning some new things. And what we're going to be focused on now are what are adjacent and vertical angles. So we're now going to be looking at specific angles, and we're looking at adjacent and vertical angles. And we're not only going to be able to know how to identify them, but in vertical angles, there's actually a special relationship that occurs between angles that are vertical. So you're not only going to know how to identify vertical and adjacent angles, but you also have to know what that special relationship is just for vertical angles. All right. So now we're going to go ahead and start talking about adjacent angles first, and then we'll talk about vertical angles second, and we'll go over some examples for each one. Actually, before we go into adjacent angles, there's one other way that you need to know how to name them. And sometimes you'll see an angle drawn with like a little number on the inside. As long as if it doesn't have that little circle up top, which that means it's degrees. So that means that we will be measuring that this is 1 degrees. If it doesn't have that little circle or degree symbol there, then that number isn't the measurement of the angle, but it's another way that we can name it. So we could actually name this angle 1 as well, because they are naming that or putting that there. So like if I put this letter B, I can say that this is angle B, that this is angle 1 because of the way they named it there. If I put the A and the C here, I can also then say angle ABC or angle CBA, and all of these will be referring to the same angle, which is this measurement here. All right, so if you see a number on the inside and there's not that degree symbol, then it's not saying that it's 1 degrees, but it's just also another way that we can name this. All right, so now we're going to discuss adjacent angles. And two angles are adjacent angles when they share a common side and have the same vertex. So that means they need to have the same endpoint and a common side as well. So when we look here, all four of these angles, angles 1, 2, 3, and 4, they all share a vertex. So right now they're all could be adjacent angles. But now we need to see, okay, well, what angles share a side? So when I see this ray being drawn here in between this angle 1 and this angle 2, well, I see that angle 1 and angle 2 share a vertex and they share a side. So if I want to name angles that are adjacent, I can say angle 1 and angle 2 are adjacent because they share that vertex and they share that side. All right, but I couldn't say, or let's talk about angle 1. Let me erase this. Let's talk about angle 1 and let's say angle 3. Well, angle 1 and angle 3, they share a vertex, but they don't share any sides because here are the two sides or rays that create the angle 3, and here are the two sides or rays that create the angle 1. So you see they don't share any side in common, so they are not adjacent. So let's go ahead and talk about some other angles here that are adjacent. So here we know that all of them share the vertex, but this one is split between angle 2 and angle 3, so we know that angle 2 and angle 3 are also adjacent. I'm just going to abbreviate that. All right, and then the same thing here, we can say that angle 4 and angle 3, because they share the vertex and the side. And then the last one we can say is angle 1 and angle 4 are also adjacent because they share that vertex and the side. All right, so just because they share a vertex does not mean that they are adjacent. So angle 4 and angle 2, they share this vertex, but they do not share any sides, so therefore they are not adjacent. Angle 4 and angle 2 are actually what we're going to discuss next. It's going to be a special, one of the other things that you're learning in this video. All right, so in order for it to be adjacent, they have to share a vertex and a side. So the last thing that we're going to be learning in this section and in this video are vertical angles. So what are vertical angles? Well, vertical angles are angles that are across or opposite from each other and are formed by two intersecting lines. And one thing that we need to know about vertical angles, besides being able to identify them, is that they are always congruent. And we're going to talk about what that means in just a moment. All right, so sometimes we can have this be nice and easy for us to identify. So if I just draw two intersecting lines here, let's just draw that black line, and let's just draw this blue line here. So you see, we actually create four different angles. So I'm going to label them 1, 2, 3, and 4. Well, vertical angles are the angles that are across or opposite from each other. So if I look at this angle 1, well, which one would you say is across or opposite from that angle? And that would be angle 3. So angle 1 and angle 3 are vertical angles. See, we would know that 1 and 2 are not because we just learned what they are, and they're adjacent because they not only share this vertex, but they share the side. So angles can't be both adjacent and vertical. So when we're looking at the next ones, well, what are other angles that we have here that are also vertical? Well, angle 4 and angle 2 are also across or opposite of each other from those two intersecting lines. So we would then say angle 4 and angle 2 are vertical angles. Right? So they are, when we have two lines that intersect, it's the angles that are directly across or opposite of each other. So sometimes it might be as simple as this, where it's really easy for us to identify. And sometimes we are going to have a lot of different rays or lines that are intersecting that kind of make this a little bit harder for us to see. But we're going to be able to identify our vertical angles by highlighting our sides of our angle that will help it maybe jump out or pop out to us. All right, so we're going to go through a couple other examples first before we talk about what congruent means, and then we're going to talk about congruent and start going through some examples of that. All right, but first I want us to be able to identify vertical angles before we start talking about this special property of them. All right, so for this example, we're asked to name all of the vertical angles. And you see, here we have more than just two lines that are intersecting. We actually have three. And I'm just going to highlight real quick and then get rid of those lines. All right, so now when we want to look at this, what I can do is I can identify or highlight two lines that are intersecting at any time. So I'm going to highlight this line, and let's just go ahead and highlight this line. So now I'm not even focusing about that blue line that's still there. I'm just focusing on these two lines here. And I can see when those two lines intersect, the angles that are opposite or across from each other will be this angle here and this angle here, and then this angle here and this angle here. So I'm only focusing on those yellow lines now. That blue one that's going in between is no longer in my vision. So I can see that if I focus on just those two, that the angle in between or the cross are the ones that I highlighted. Now, when I said before that there's going to be times where we have to label using all three, if I just said angle J here, which angle are you referring to? Because all of these angles actually have J as our vertex. So if you wanted to just say angle J, I have no idea which one you're talking about. So when you have multiple angles that are formed from the same vertex, you must use the three letters to name. So when I see here, if I want to name this angle that I have here, I would have to label this angle Q, J, K. And then the angle that it is vertical with, I'm just going to list it right next to it, and that's the one across, and that would be M, J, N, or you could say NJM as well. It doesn't really matter which way you do it, right? But we know that they are vertical angles. Then the next one that we can talk about here are these vertical angles. So I can name that NJQ, and I can name this one KJM. Right, so they are vertical angles. So now if I erase this, instead of highlighting those two, I can now highlight this one and this one. So now I'm focusing on different angles here, and I can see, well, the ones that are crossing each other will be my angles there, and it'll be my angles here. So I'm going to go ahead and say, well, this angle is going to be vertical to this one, and the green ones are vertical to each other as well. So even though there's multiple angles going on here and multiple lines, I can just focus on two at a time to help me see a little bit better. So I can say angle PJQ is going to be vertical to angle LJM. And then I can say angle PJM is vertical to angle QJL. So you see, I'm just focusing on these at two of them at a time. And then the last ones I would have to focus on could be this one here and this one here. All right, so by doing this, now I focus on all the different pairs that I can make. And here I would have these two angles, and then here I would have these two angles. So let me go ahead and name them. So I can have angle P, J, N is vertical to angle K, J, L. And then I can say that this angle N, J, L is vertical to angle K, JP. All right, so that's listing and naming our angles that we have there. All right, so it's important for you to be able to see that sometimes we will have a little bit harder looking ones, and we have to kind of think about all the different ways that we can look at this. But the main thing is, remember, vertical angles are formed when two lines intersect. So if we ever have trouble, just try and identify the two lines that are intersecting, and then we can focus on just those two lines. Like that's why I was highlighting here, where I was highlighting the lines that we're focusing on. So now it allows me to just focus on those ones and kind of forget about that blue line that we aren't highlighting there. All right, now there's one more example that we're going to go through before we start talking about the congruent angles. All right, now this one looks a little bit different. It's almost similar to the one that we just did. However, you can see that this ray that we have doesn't extend, so it's not actually a line, but it's a ray. So it looks a little bit different. So when we're identifying our vertical angles, I know I'm not going to use this ray at all because a vertical angle or where two lines intersect, and that's a ray. So that means that that part is not going to create any vertical angles for us. So I can then focus on this line and this line here to then create my vertical angles. So sometimes we might have that ray in there that may confuse us a little bit. But remember, when we're looking at vertical angles, it's the intersection of two lines. So identify the two lines that we're intersecting, and then that will allow for us to visually see which ones are across from each other or opposite. So I can see that this angle is opposite of this angle, and I can see that this one here is opposite of this one here as well. So that blue ray that's there can kind of just be there to confuse us a little bit. It might be very important for the problem that we're doing, but it just doesn't pertain to vertical angles. So if I want to list my vertical angles, I would then say angle A, B, F, and angle D, B, C. That's our vertical angles here. And then our last ones that we have are angle A, B, C, and you could have said CBA, and angle F, B, D. All right, so remember, it's the intersection of two lines and the angles opposite are crossing them. So we actually don't even need to worry about this ray here to help us with any of these vertical angles that we have. All right, so that's it for the vertical angles part. So now let's talk about what it means to be congruent and how that applies to vertical angles. Right, so congruent angles are angles that have the same measurement. So we can just kind of say that they're equal to each other. So if I give you that there is a measurement of angle A is equal to 35 degrees, and I said that angle A is congruent, and the way that we represent that is this equal sign with a little squiggly on top of it, is congruent to angle B. Well, that means that the measurement of angle B, sorry, I should have had a little angle there. The measurement of angle B is also equal to 35 degrees. All right, so when we say that two angles are congruent, this means that they have the exact same measurement. So if we tell you what one of them are equal to, then we know that the other has to be the same thing. And one of the things that we learned or that we said is vertical angles are congruent. So that means that if we know that two angles are vertical, that they have the exact same measurement. So if I know what one of their angle measurements are, then I know what the other one is as well. All right, so now we're going to go ahead and actually solve a few problems using what we learned with adjacent, identifying adjacent angles, and what we know about classifying angles. And we're also going to solve some problems with some vertical angles. All right, so if I ask you to solve for x here, well, what we would have to do first is try to identify, is there any relationship that we have? And when we see that we have two lines that intersect, like we do here, then we know, well, when two lines intersect, we might have some vertical angles. So we're looking and saying, okay, well, angle X and angle 70 are across or opposite from each other. So we know that they're congruent. And the way that we can represent that in our figure is, you saw me drawing these little arc marks. When we draw one arc mark to each other, that means that they're the same measurement. And when I draw two arc marks here, that means that these are the same measurement as well. So if we want to represent things being equal, like angles, we just draw these arc marks, and that represents that they're the same measurement. But since we don't know that x and that the green arc and the red arc are equal, and if we actually were to prove this or solve this, we can actually show that they're not. But since we don't know that they're the same measurement, we would denote it by using different amount of arc marks. So if there's a third angle here, we can write three arc marks to show that they're equal or congruent. So the arc marks represent that they're the same. Well, since angle X and angle 70 are vertical angles, I can then say that X is equal to 70, since it is congruent or equal to the opposite angle as well, because they are vertical. All right, now here's another example we're going to do, solve for X. So this one's now taking a few things that we learned. So first off, when I see this angle here, and with this box here, well, what does that mean? That means that this little green angle that I drew, that it's a right angle. And we know that right angles measure to be 90 degrees. All right, so now what we're looking for is, we see that these two angles, that this angle, I'm going to label this 1, and this angle 2, that they share a vertex and they share a side. So when they share a vertex and when they share a side, that means that they are adjacent to each other. And when we have two adjacent angles that form a right angle, then I can say that the measurement of angle 1 plus the measurement of angle 2 is equal to 90 degrees. You see, since they're adjacent, there's no gap or there's no separation between the two, and those two come together to form a right angle, that if I could somehow get rid of that purple line and redraw this, that it would form this perfect right angle. And we know that those two angles then have to equal 90 degrees. So then that means what I can do is, instead of looking at it like this, well, I can start substituting things in. Measure of angle 1, well, I said that angle 1 was this, so angle 1 is represented by x plus 4. And then this angle 2 here, they tell us is 31 degrees. So instead of saying measure of angle 2, I can say plus 32 is then equal to 90. And now this is just a basic equation that we can solve. 4 plus 32 is 36, so x plus 36 is equal to 90. We can subtract our 36, and that means that x is then equal to 54. So when we know that in order for this to be adjacent and give us a right angle, that x had to be 54 degrees. So when we're dealing with vertical angles, we need to be able to identify them and say that they're equal to each other. And when we're dealing with adjacent, sometimes we'll have to use these rules and to say, all right, well, adjacent angles, that those two come together to form the bigger angle that we have. Right, and then there's one more example I want to go through before I start having you try some things on your own, and then us helping each other and working with each other, is something like this. All right, so now you're asked to solve for x. So this one here, we can see that they're adjacent because they share this side and they share the vertex, right? So we know that's adjacent. So in order for you to solve this, so you need to know how to call, or what we can name this, straight angle. Well, I just set it for you there. It is a straight angle. So you see it forms a perfectly straight line. Well, do you know what a straight angle's measurement is? This entire angle measurement is equal to 180 degrees. So that I know that these two angles, once again, let's just label them angle 1 and angle 2. I know that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees because it forms a straight line. So when they form a straight line, that is 180 degrees. So now to solve for this, I can just substitute in. Well, 1 I said was x, so I can say x plus 85 is equal to 180. And I can subtract 85 from both sides, and x is then equal to 95. All right, so this is another angle relationship and classification that you'll need to know as far as like the acute, obtuse, right. Right gives us a 90 degrees, and then also a straight angle gives us 180. All right, that is it for this video, and that's it for this section.